I'm going to walk through this really quickly. I'm going to take a super simple data set, super simple model, so that we focus more on the intelligent experimentation aspect of things as opposed to the model itself. So I'm going to take the breast cancer data set that's available in scikit-learn. I'm going to use the XGBoost classifier, one of the most popular frameworks in the world for doing kind of gradient boosted machines based classification. And we're going to end up trying to tune a method that maximizes the recall for each one of these labels for this kind of medical application. But first up, here is the entire model. And again, it grabs the data set from scikit-learn. It parameterizes it. You can see here at the very beginning, we're starting to track some of these design decisions that were being made, the data set, the model, et cetera. And then at the very bottom, we're tracking things like the various output metrics, averages and weighted averages of the various classes, their F1 scores, precision, recall, and support, et cetera. All of this being kind of piped up to SigOpt as we go. One thing I'll point out, though, here in the middle is this is a very typical example of what we've seen in the real world, where people will build the model and either not set these hyperparameters like number of estimators, max depth, learning rate, et cetera, and just take the defaults, or start tuning and tweaking these by hand. A lot of times the defaults in these machine learning frameworks are designed to make a specific example look good or maybe run fast, but might not actually be the best sets of parameters for your production application. With one line of code, what we're going to do is we're going to kind of abstract away those constants, and we're going to start tracking them within SigOpt, in addition to some of these modeling decisions and the output metrics themselves. So we can still put in the defaults, as you can see here, the number of estimators, the max depth, et cetera. But now as we set those, instead of trying to manually tune this three-dimensional space in our head, each one of those outputs is going to be tracked by SigOpt. As we do this and maybe try a couple of different things to gain intuition, again, instead of trying to keep track of a dozen different metrics and the input parameters and things like that in our head, we can quickly go to the dashboard and start to see some patterns, start to see, okay, certain learning rates seem to have a specific impact. We get more support in certain areas, et cetera. But ultimately, we can start trying to say, of all the metrics that we care about, what's something that we want to start maybe optimizing towards? So we've gone through the design phase of selecting a model and we're tracking everything. Now in this exploration phase, we're really trying to find a good objective metric or maybe set of objective metrics that we want to optimize for. One thing we'll note with this, even these 6 runs that we did manually here, is we can see, we start to see a pretty big spread in terms of the accuracy itself. We see like a 90%, a 94%, et cetera. So again, while our main case was to maximize the recall of both of these classes, we might want to start thinking about accuracy as something that we care about as well. So with SigOpt, this now allows us to start phrasing the question, giving us something to optimize towards. So again, in a few lines of code here, we're telling SigOpt that we're creating an experiment. We're tuning these 3 parameters and giving it a range of some integers and some double precision parameters to tune for, and any transformations that you might have on these parameters themselves. We'll tell SigOpt about the metrics that we're optimizing for. Certain ones we will want to maximize, certain ones we want to minimize, certain ones we just want to store and keep track of, like these precision metrics. Certain ones like recall we want to explicitly optimize for. So you'll see we're optimizing across these 2 metrics. And certain ones we might just want to put a constraint on. So I talked about accuracy maybe being an important metric that we care about. So let's say we want the best recall we can across both classes, with a constraint being that we want the accuracy to be at least 95% for the entire model as well. And now we just go through this loop of creating the model in the exact same way that we would have done before. Only now it's just, while the experiment is not finished, we're pulling down suggestions, getting suggestions from the SigOpt software as a service interface, evaluating them, reporting back those metrics. And as we loop over this, we're able to very quickly get to a set of results that are very interesting. So jumping back to the dashboard here, we can see that there's a set of gray points along this Pareto frontier, this efficient trade-off between the recall of both sets. These gray points don't meet that 95% accuracy threshold. These blue points do, but aren't as good as these orange points, these Pareto optimal points that are the best we can do in any one metric without giving up performance in the other metric. And so now, with a few lines of code, taking it just from the simple scikit-learn example, we've started tracking everything. We've started exploring a bunch of different metrics. We've designed an optimization problem and solved it across two different output metrics and a threshold to find two different models that satisfy our business constraints and our accuracy constraints. And ultimately, we could push into production and see how well they did. And then as we're exploring this, again, there's many different ways to, after you've actually done the optimization, go back to exploration. Start looking at how all of these different metrics traded off with different parameters, and maybe gaining insights on how we might want to shrink down or change the learning rate and log space here, et cetera. This is not a linear process. What I'm showing you here in this demo is just one potential path. There's many different paths, but it ends up being a cyclic problem where you're constantly going back to ask different questions, explore different metrics, etc. So at the highest level, what this has allowed you to do with a few lines of code after a quick pip install SigOpt is design your experiments, explore your experiments, and ultimately optimize your experiments to hit your business needs. So that's SigOpt in a nutshell. Again, all of this is available for free today. If you go to sigopt.com/sign up, you can be up and optimizing by the time I'm done with my Q&A. And we look forward to helping you achieve the best possible results for your models, spending less time on trial and error and more time with a collaborative, intelligent experimentation platform.